Combination circuit, question 2. In this circuit we have a 60-volt battery. It again is a combination circuit as it runs serial through here, through this first resistor of 5 ohms, and then it will split the current this way. Because these resistors are of equal weighting, the current will split equally on both sides, come back together here, and then pass through this resistor, and back to the battery. First question asks you to find the total resistance. Well, we already know R1 and R4 of 6 ohms. We need to find this. So the total resistance is going to be the 5 ohms plus the 6 ohms. And then, as mentioned, we need to figure out the current through here. So this current, I'll call this the resistor parallel part. 1 over resistor parallel is equal to 1 over 8 plus 1 over 8. Doing the math, we find that this becomes 4 ohms. Therefore, we can add 4 ohms to our resistance total for a total of 15 ohms. Total current. Total current will simply be the total, the voltage total divided by the resistance total. So IT, total current, is equal to the total voltage divided by the total resistance. So 60 volts divided by 15 ohms. By doing the math, we find that this comes to 4 amps. Find the voltage drop at resistor R1. So resistor R1, we have a resistance of 5 ohms. We know the current through that location has to be the same as before, so it has to be the 4 amps. So this here is 4 amps. So I can simply calculate the voltage drop there by going voltage is the current times the resistance. So in this case, it is 5 ohms and 4 amps, so 4 times 5. Therefore, we lose 20 volts across that resistor. The resistor drop at 4, the voltage drop, at resistor 4 is going to be the same idea. V equals IR. The current is the same because it's back into the serial section, but we have a 6 ohm resistor, so it would be times 6. So we'd have a 24 volt drop. Now it says to find the current through resistor 2 and resistor 3. So these are these resistors here. They are going to be the same amount. And because we have 4 amps appearing here, that would mean that 2 amps and 2 amps would have to pass through there. So without doing any calculation, I know that this is 2 amps and this is 2 amps. To double check that we're getting the right voltage drops, we could simply multiply the current, 2 amps, times the resistance to find the voltage drop would be 16 volts here and 16 volts at the other resistor. The sum of these must add up to the 60 volt battery. Since these are in parallel, we'd only count one of them, so we can see here that 20 plus 24 plus 16 would give us the 60 volts that we're looking for.